Welcome to Brain Vision.
While solving these problems, we prepare an ICE table and substitute the concentration value in equilibrium constant. We make an approximation and solve the equilibrium constant expression to obtain a value of x, where x is a change in concentration. Then check if the approximation is valid. The equilibrium constant expression for any reaction can be represented as A inversely proportional to B, where the equilibrium constant is concentration of product by divided by the concentration of reactant is equal to 1.0 into 10 raised to power negative 4. These are the basic values. For option A, let us consider X be the change in concentration of A to reach an equilibrium. Again, drawing an ICE table, we substitute the equilibrium constant value into the expression. Substituting those values, we have x equal 1.0 into 10 raised to power negative 7m. Yes, where x is a small approximation is valid up to the percentage of 5%. So, since the ratio over here is less than 5%, the approximation is valid. For option B, again, let x be the concentration change of A to reach an equilibrium point B. We substitute the values again into the same equation and we assume that x is very small in comparison to 10 raised in comparison to 0.10 minus x. Hence, we replace 0.10 minus x with 0.10 because the value of x is too small. Here, the value of x is greater than 0.10 m, but x should be less than 0.10, so this case is a positive. The approximation is greater than 5%, so it is invalid. Same with option C. Let x be the change in concentration of A to reach the equilibrium. We substitute the values into the equilibrium constant expression, assuming that x is very small. In this case, the x turn out to be 1.0 into 10 raised to power negative 5. We check that x is very small in approximation, that is about 1%. Since 1% is less than 5%, the approximation in this case is valid.